Hello everyone, my name is Huixu. I will sharing about some videos to solve the political problems. And so, what problems I will solve today? Well, there is a quest in the LRU code. Let me share my screen. It is called the Offer Expedition Campaign. The LRU Cache. The get and put must each run in over one average time complexity. Okay, so for um, the experienced people, the LRU cache is a very typical problem. And I have also done this problem before, so let's just clear the previous answers. And what is the problem exactly about? It is a class called LRU Cache, and we should implement the initialize function, the get function, and the put function. The get is to get the value of the key. The put is to update the value of the key if the value exists, if the key exists. Otherwise, if the otherwise we will add the key value pair. And if the number of keys exceed the capacity from this operation, evict the least recently used key. And this is a very typical problem, so the solution for this is to build the data structure that ensures that the get input running over one average time complexity. So what is the data structure that we add and delete? Because we need to find the data structure. Um, so let's use this. Okay, so we need to find the data structure that with add and which is the put. Add and delete with O of 1 time complexity. So what is this data structure? Well, the data structure of this is linked list. Um, so the linked list for we will use a linked list for this problem. We'll define the list node. The list node the parameters for this list node contains the key and the value. And we should go to the previous very easily and go to the next very easily. So this is the list node. And we will use a head node to save the key and value, and and the latest node, the latest recent or the most recent node will be at the head. And there is another node called tail. And the head next is tail, and the tail previous is the head. Why we need the tail? Because the head is the most recent. The tail is the least recent. And we also need to use the key to find the value. So we need a dictionary. The dictionary is from the key to the list node. And we will use the default dict. So with the key, we can find the list node. And there is another variable called capacity. And after that, we can easily get the value of the key. So we will get the node, the list node from the key to, okay, I think I can use this. Key to list node with the key as the key. And after that, we will return the node. And before that, we'll check whether the key exists or not. So if key not in key to list node, we'll return -1. Otherwise, we will return node value. But because we have recent visited this key, So we should put this key to the head. So how can we put this key to the head? Well, we should find the previous, which is the node previous, the next, which is the, okay, actually we should remove the node from the linked list. And then we should add to head. So we should write these two function remove the node, remove. Okay, so how can we remove the node? We should get the previous from the previous and the next from the next. And previous next. Is next. Next previous is previous. And node previous is none. Node next is none. So this is remove. And add to head. Previous. Add to head. Previous is the head. So we'll get the next from the head next. Head next is node. Node previous is the head. Node next is the next. Next previous is a node. So this is the get. We'll need to is remove and add to head so that we can ensure that after we call this, we will put this key and value to the most recent visited position. And for the put, we should check if key exists in the key to list node. We can directly update this, which is key. Okay. Directly update the node with key to list node key and the node value equals to the value. After that, we will call the remove of the node and add to head with a node. So we update the value and update the most recent visited key and value, and we can return. Otherwise, if it didn't exist, we should check whether the length is exceeded the capacity or not. So we should check the length of the key to list node. So if the length of the key to list node is larger than is equals to the capacity, we will delete the least recent key value from the list node as well as the key to list node. So we can get the node from the tail previous. And we will remove the node. And node has the key. So we will get the key from the node key and delete key to list node with the key of the key. We can directly, okay, I just use this. Or we just use the node key here. After that, we can add the key and value to the LRU. So we will add the node with key to list node. The key is the key. So actually we should define the list node. With the key is the key and the value is the value. Key and value. Okay. After that, we will update the key to list node with the key is the key and the node is the node. And after that, we will add to head of the node. Okay, we should go through, actually, we should go through the code. Add to head, add to head. Okay. Okay, we just get the correct answer for this example. And let's check. Okay. We just solved this problem. So this problem actually is a medium problem. It's not the hard problem. It's because it seems very easy when I try to solve this problem, and the the time complexity for both of the get input is so 1 because we just add and delete using the linked list. And the key for this problem is that we define the data structure with a head and tail, which is the most recent and the least recent, and a dictionary called key to list node, so that we can directly go from the key to the list node in the linked list. And to update the recent, we just remove the node and add it to the head. And for the put, if the key already exists, we just edit it and update the recent node. Otherwise, we should check the capacity and ensure that the capacity, we just evict the least recently used key and update the key and value to the list node and the key to the list node. So if we can design this data structure, we can solve this problem very easily. So this is the problem about the LRU cache, and I will solve the next problems. And if it is if it is helpful for you, you can like this video. I will share more analytical problems and share more useful things in my channel.